आज हामी नेट जेआरएफ जुन 2016 को only quantum mechanics questions we will solve. So the first question is, and the question is asking us to find the possible energy outcome and the total average value of energy, and the options are given. First two options are for the energy values, and the second option is the average energy, right? So first of all, what this wave function looks like, we have to first relate it with whatever the system we know. There are different systems. One is harmonic oscillator, second is your hydrogen atom, third is your particle in a box, right? And or potential whale, like that. These kinds of different systems we already know, and the wave functions related to those systems, those should also be memorized, learned by ourselves. Okay, so this is a wave function. This wave function looks like psi n x for a one-dimensional potential whale is under root 2 by length. If I consider the L to be the length of the whale, then sine n pi x by L. So from here we can easily relate that this is a value of 2 and this is your n value is 4, but the first terms are different. But we can say E2 is equals to n square pi square h squared square upon 2m L square. So basically this is En. So E2 will be 4 pi square h squared square upon 2m L square. But in our options it is not in h squared, so we have to h square upon, because h square is h squared is nothing but h by 2 pi. So is square is h square by this square, so 4 pi square will get cancelled and we will be left with 2m L square. Is that okay? Second is E4 is this 4 square is 16, and this h square pi square divided by 2m L square into 4 pi square. This 4 pi is coming out from h. This will get cancelled. 4 to the 8, 2 h square. So this is 2 h square upon m L square. So these are the two energy outcomes. Okay, so these are, if you check the options, you'll see option A and C will match, but our average energy term is yet to be found out. But this psi x, this can be written as, with respect to this generalized wave function, we can also 3 by 5 and then under root 2 by L sine 2 pi x by L plus 4 by 5 under root 2 by L sine 4 pi x by L. Right, I have distributed this 2 by L. So this will be 3 by 5, and this is nothing but, if I write in this gate, this is nothing but phi 2 plus 4 by 5 phi, this one is 4. Okay, so average energy is nothing but, this is a trick, or you can simply say the formula you can memorize, sum over Pn En, where Pn is the probability corresponding to particular state and En is the energy for that particular state. So this will be, Pn is this one coefficient square, so 3 by 5 square into this is E2 plus 4 by 5 square into this is E4. So energy we already know, n square pi square h squared square, this one, right? So 9 by 25. N square is for the second case, 2 is n square is 4, and I can say this pi square h square upon 2ml square to be e1 plus 16 by 25 into 16 e1, right? So the value, after solving, the value will come out to be this e1 and this e1 is same thing, right? The value of e1 I'll just write here, pi square h square upon 2ml square. So I don't want this h square, so it will be h square upon 8ml square, right? H square upon 8ml square. Whatever you solve from the first case, you will get 73 upon 50 h square upon ml square, and option A is your correct answer. And the next question is this one. It is given the commutator operator, and we have to solve it, or we have to simplify it. Okay. Components of angular momentum operator is given, and firstly we have to solve the Lx, Ly, Lz. These are all operators, is what they are asking us. And the thing I want is that L, I, L, J is nothing but iota h cut epsilon L k, and then epsilon I j k. This is the solution, or you can say the process. Well, if it is counterclockwise, then we will get the negative sign. If it's clockwise, then it's okay, I j k. Okay. Now next thing is we have to solve this one. 1 a b c is equals to a b. We have to first couple it with b and then couple it with c. C plus a c. Now it will go, we should couple it with c, but this b will be in the left side, right? So this concept will apply here. First of all, we will take this as b, this as c. So Lx, Ly, right? What will be left outside? Lz plus again Lx, Lz, but what will be left outside? Lx, Ly, right? These are all operators. So this has been simplified, but this is yet to be simplified. Again, same concept, Lx with Lx outside Ly and Lz plus Lx with Ly, Lx, and this Lz will be left here, then Lx, Ly, and then Lx, Lz. Okay. Now Lx with Lx will come out to be 0. Then Lx with y, xy will get iota h cut Lz. So Lx iota h cut Lz, and this is also Lz outside, plus Lx, Ly, xz. This is x, y, z, and this is the process, but this is xz opposite. So Lx, Ly minus iota h cut L, xz is y, zz is iota h cut Lx, Lz square minus Ly square, and the option is A is the correct. Okay, this is the next question, and here it is given that Br is equals to, this is the potential, and E and Lm. This modified, this depends on N, L and M. How does it depends is, this has been asked. Okay, but have you ever noticed about this second term? This potential is a central potential, and for central potential we always know that the angular momentum is always conserved. For central potential, angular momentum is always conserved. So if angular momentum is conserved, then this dependency on L and M will not be there. So the only dependency left is with N. So our actual correct option will be depend on N but not on L and M, that is B. And the next question is the eigenstates corresponding to eigenvalues E1 and E2 of a time independent. अच्छा, one वेव फंक्शन, इधर एक वेव फंक्शन दिया हुआ है psi at time t equals 0, right? This is nothing but sin theta 1 plus cos theta 2. Then they are asking us the value of psi t. Okay, there is a trick to know, and as well as the detailed method. First I will do with the detailed method and I'll tell you the trick of this one. Okay, now we have the wave function which is at time t equals to 0. Then after later time, if you want to know the wave function, then it will be nothing but psi at t is equals to psi at 0 e to the power minus iota e t upon h cut. This is the energy at a wave function at a later time t. So similarly this same concept we will apply here, but in this case this one will represent E1, this one will have eigenvalue E2. So corresponding to those values, psi at later time t will be nothing but sin theta 1 e to the power minus iota E1 t upon h cut plus cos theta 2 e to the power minus iota E2 t upon h cut. Is that okay? Now we need to find the bra of this one. T will be nothing but sin theta will not change, sin theta 1 exponential iota will change, iota E1 t upon h cut plus cos theta 2 e to the power iota E2 t upon h cut. So psi t will give me sin square theta 1 plus cos square theta 2 which is nothing but sin square theta plus cos square theta which is nothing but 1. This was the detailed method, but the trick is that the wave function is always normalized. If it is normalized, then at a later time or the initial time, if it is normalized here, then at later time it will also again it will be normalized. So this is a case for normalization, normalization case. So its value will be equals to 1. Okay, this is the next question, in which potential is given to be half m omega square x square plus there is some perturbed potential, okay, cos kx. So it is asking us to find the change in ground state energy. Change in ground state energy compared to the simple harmonic oscillator potential, this one, to the first order in G is, okay, and the options are like that. But first of all, what we need to know is the ground state wave function of a harmonic oscillator. Ground state wave function of a harmonic oscillator is m omega upon pi h cut to the power 1 by 4 exponential minus m omega upon 2 h cut into x square. Okay, this is the ground state wave function of a harmonic oscillator. What we need to know is that this is a part of potential, that is g cos kx. This is the part of potential, and it is also can be written as g by 2 e to the power iota kx plus e to the power minus iota kx, right? So ground state correction to the ground state energy is given by psi naught Vp psi naught. This is the correction in ground state energy, right? And this is the complex conjugate, that is bra, and we can check it with the wave function. There is no iota term, so it will be just the product, as well as the perturbation is also, there is no differentiation term, so we have to directly multiply, no need to operate anything. So this will be m omega on pi h cut to the power 1 by 2, and then integral from minus infinity to plus infinity e to the power, first of all I'll write this one, e to the power minus m omega upon h cut x square e to the power iota kx plus e to the power minus iota kx and dx. Is it okay? This we have to further m omega upon pi h cut to the power 1 by 2 integral over minus infinity to plus infinity e to the power minus m omega upon h cut x square plus this one iota kx plus e to the power minus m omega upon h cut x square minus iota kx, and this is whole dx, right? And further, to solve this integral, we have a formula that you should memorize. This is integral from minus infinity to plus infinity e to the power minus alpha x square plus beta x dx. If the form is just like this, then it will be under root pi by alpha e to the power minus beta square by 4 alpha. Tick. This is the solution. So if we check out here, it is minus infinity plus infinity e to the minus m omega upon pi h cut m omega and h cut, that is our alpha, m omega and h cut is our alpha x square plus beta is iota kx. Okay, so we will apply this here. Now this will be m omega upon pi h cut to the power half. Okay, I'll first of all I'll distribute the integral minus infinity to plus infinity e to the power minus m omega upon h cut x square plus iota k x dx plus minus infinity to plus infinity, and then minus infinity to plus infinity e to the power minus m omega upon h cot x square minus iota k and x with a dx, and the bracket is closed. Okay, now just apply the formula. Now m omega upon pi h cot to the power 1/2, and then for this first term is under root pi by what is alpha? It is nothing but m omega upon h cot whole power half exponential minus of what is beta square? Beta square is iota k square upon 4 into what is alpha? M omega upon h cot, m omega upon h cot, right? One thing is done, plus similar the second term, pi upon m omega upon h cot whole to the power 1/2 exponential minus this one is minus iota k square upon 4 m omega upon h cot to the power, no, it is only this one exponential, and the bracket is closed. Now m omega upon pi h cot to the power 1/2, and if we solve this one, I will get pi h cot upon m omega to the power 1/2 exponential of this iota square will give you negative sign, so h cot k square divided by 4 m omega plus same thing pi h cot upon m omega to the power 1/2, and then exponential h cot k square upon h cot k square upon, okay, negative, oh, there is a negative term h cot k square upon, oh no, this iota, this negative square will give us and positive, iota square will give negative, that negative and this negative, as well as this one will give positive sign. I was correct. And then k square upon 4 m omega, and the bracket is closed. Now again we have to distribute this one with this one, it will give us value 1. So our after integral the value will come out to be this one. If sign here, it will be positive, so we will correct it accordingly. From this is positive, and as well as this is also positive, so overall this will come out to be negative. Okay, this will come out to be negative, this will also come out to be negative, and this is negative, and as well as this is negative. So our option D is matching, right? Option D is matching.